Hello everyone, this video will show how to evaluate inverse trigonometric function. So we're going to start with inverse sine or arc sine. So we remember that the range for arc sine is from negative pi over 2 to pi over 2, which means that arc sine values are defined only in the first and fourth quadrant. So I'm going to go ahead and cross out the second and third. So we're going to label this unit circle right here. I'm going to give you a trick. So the first thing that I need to do is to write down the parentheses. Okay, so the trick here is that all of these will have a denominator of 2. So I'm going to write it down here. Now for the numerator, we're going to start with 1 on the top here. So that's 1. 2, but I'll put that as square root of 2, and then 3, which is the square root of 3. And then we do the reverse. That would be 1, 2, and 3. But then the 2 and 3 will have square root on them. Right here, the coordinate for this is 1, 0. And up here, the coordinate for this is 0, 1. Since we say that the range for arc sine is from negative pi over 2 to pi over 2, that means this is only for the positive side. Now let's see the negative side down here. So we go ahead and match these two up. So these points are a match. However, this side right here will have a negative y. So I'm just going to go ahead and rewrite this with a negative y. And the next thing that we need to do is to write down the angles. So in this case right here, we're going to start with this. So remember, if it's 30, that would be anything that's divisible by 30 will have a denominator of 6. So this would be pi over 6. And this 60 will have 2 pi over 6. But when we reduce that, that's pi over 3. So 1 pi over 6, 2 pi over 6. This is 3 pi over 6, or this is pi over 2. And for the 45, that will have a denominator of 4. So this will be pi over 4. So what are we going to do is we're going to reflect it across. Since we're going clockwise direction, we're going to reflect this, but the angle will be negative. So this will be negative pi over 6. This will be negative pi over 4. This will be negative pi over 3. And this is negative pi over 2. So if you notice, the range now is from negative pi over 2 up to pi over 2. So all arc sine functions are defined only in the first and fourth quadrant. So we go ahead and determine the values for each of these. So this notation right here means that we're looking for that angle such that the sine, which is the y-coordinate, is negative square root of 2 over 2. So we're looking for that y-coordinate that is negative square root of 2 over 2. And this is the value right here. Because we're looking for the y-coordinate that is negative square root of 2 over 2. And that angle is negative pi over 4. So the answer for this is negative pi over 4. So for the next problem, we're looking for that angle that has a y-coordinate of positive 1/2. So we're going to trace it. The positive 1/2 is right here. So the answer for this is pi over 6. So in this next problem right here, we're looking for that angle that has a y-coordinate of square root of 3 over 2. So that is pi over 3. So I'm going to put that down here. And then the next one here, we're looking for that angle that has a y-coordinate of positive 1. So the one that has a positive 1 is up here, which is pi over 2. And for the next one right here, we're looking for that angle that has a y-coordinate of 0. So in this case right here, the y-coordinate that is 0 is on 0. This is, by the way, 0 degrees. So this is 0 right here. Now for the next one right here, we're looking for that angle that has a y-coordinate of 2. If you notice, the y-coordinate for arc sine starts from negative 1 to 1. So this is undefined. The reason for this is this fails the domain rule, which means that the domain for arc sine should only start from negative 1 all the way to positive 1. Now let's go over arc cosine problems. We remember that the range for arc cosine is from 0 to pi, which means that arc cosine or inverse cosine values are defined on the first and second quadrant. So I'm just going to go ahead and cross out the third and fourth quadrants here. The next thing that we need to do here is to label the coordinates for each of the points from the first to the second quadrant. I'll start with the first quadrant. It's the same trick that we did in the arc sine examples. So you can set it up with denominators of 2, and we're going to start with 1 square root of 2 square root of 3. Then we do the reverse, 1 square root of 2 square root of 3. And the coordinate for this one down here is 1, 0, and this is 0, 1. Now what we do on the other side here is we reflect these coordinates. So these are the same, these two are the same, these two are the same, but the thing is our x here is negative. So I'm just going to go ahead and rewrite this with a negative x. And the coordinate that we have right here is the opposite of this one as well. So this is negative 1, 0. Now we're going to write the angles for this. So we always start with 0 down here. Anything that is divisible by 30 will have a denominator of 6. So this will be 1 pi over 6. This is 2 pi over 6 or pi over 3 when you reduce it. This is 3 pi over 6 or pi over 2. And this one right here is 4 pi over 6. When you reduce that, that is 2 pi over 3. And this is 5 pi over 6. And this one right here is 6 pi over 6, or that is just pi. And then for the 45, we will start with 1 pi over 4. And this is 2 pi over 4, which we already have pi over 2 here. And then this one right here will have 3 pi over 4. So this is 3 pi over 4. Now we're going to evaluate this given expression that we have right here. So the one that we're looking for right now is the angle that has an x coordinate of square root of 3 over 2. So we're going to trace it up. On the x coordinate, it should be square root of 3 over 2, and that is pi over 6. So the answer for this is pi over 6. For the next one here, we're looking for that angle that has an x coordinate of negative square root of 2 over 2. So we're tracing the x coordinate, negative square root of 2 over 2, and that is 3 pi over 4. For the next one right here, we're looking for that angle that has an x coordinate of negative 1/2. So we're tracing negative 1/2 right here, and that is 2 pi over 3. And then for the next one here, we're looking for that angle that is an x coordinate of 0. X coordinate of 0, and that is pi over 2. And then for the next one here, we're looking for that angle that is an x coordinate of negative 1. X coordinate of negative 1 is pi. And then for the next one right here, we're looking for that angle that is an x coordinate of 3. Now, if you notice, the x coordinate here starts only from positive 1 all the way to negative 1. Anything outside of this values will be undefined. So 3 is bigger than 1. So we go ahead and say that this is undefined. So the reason for this is this fails the domain rule for arc cosine. The values for arc cosine would start from negative 1 to positive 1. Now let's have arc tangent problems. We remember that the range for arc tangent is from negative pi over 2 to pi over 2, which means that arc tangent is only defined on the first and fourth quadrant. So I'm going to go ahead and cross out the second and third quadrant. Now we remember that tangent is actually equal to sine over cosine. So you can determine the sine over cosine for each of the points here, but I'll give you a trick. So these are the values for tangent. First, this one right here will be square root of 3. This one is 1, and this is square root of 3 over 3. And this one right here, we have 0 over 1, so this is 0. And up here, it's going to be undefined. And we're going to reflect this across on the other side here, which in this case, we will have negative square root of 3 over 3. this will be negative 1, and this will be negative square root of 3. For the case that we have right here, since the coordinate for this is 0, 1, so 1 divided by 0 is also undefined, the same thing as that up there. So we're going to label the angles for each of these. So anything that is by 30, that would be over 6, so 1 pi over 6. 2 pi over 6, which can be reduced to pi over 3. And this is 3 pi over 6 or pi over 2. And then on the other hand, we will have the 45, so that is pi over 4. This is for counterclockwise direction with positive angles. Since we say that the range for arctangent is from negative pi over 2 to pi over 2, then we can go ahead and label the angle that is clockwise direction, which becomes a negative. So in this case right here, this will be a match, but this will be negative pi over 6. This one right here will be negative pi over 4. And this one is negative pi over 3. So we go ahead and evaluate each of these. So we're looking for that angle that will have a value of negative square root of 3. So we trace it up, and that is on negative pi over 3. So this one right here is negative pi over 3. So we're looking for that angle. So in the next problem here, we're looking for that angle that has a value of square root of 3 over 3. And so that is pi over 6. And then for the next one here, we're looking for that angle that has a tangent value of negative square root of 3 over 3, which in this case is negative pi over 6. And for the next one, we're looking for that angle that will have a tangent value of negative 1. Tracing it up, it is on negative pi over 4. And then for the next one, that is we're looking for that angle that has a tangent value of positive 1, and that is pi over 4. For the next one right here, we're looking for that angle that has a tangent value of 0, and that is on 0. So that is how we evaluate inverse sine, inverse cosine, and inverse tangent, or arctangent, arcsine, and arccosine function.